My name is Roman Grigorii. I'm a graduate student here at Northwestern, Mechanical Engineering Department, and I work in Neuroscience Robotics Laboratory. And the title of my talk today is Touching the Virtual. Before I get into that, I want to talk about media and what it means for us. Media is a means of communication. And we use digital media for a vast variety of applications in everyday life. We use it for educational purposes, to read a book, for example, on a Kindle or a Nook, or read a news story online. We use it for entertainment or social purposes, for example, to talk to our friends online, or to watch television or listen to music. And then everything else that's not included in those two, I call utility. So, for example, for navigational purposes, we use a phone to navigate somewhere. And there are some problems with digital media, but the problem that I want to discuss is not with digital media per se, but with the way we interact with it. And the problem is that we use two modes of interaction with it. We either look at it or we listen to it. Why is this a problem? Well, first of all, it leaves out a large number of people from the loop. People who are visually or hearing impaired who cannot access digital media easily. It's a problem for them. Also, it's demanding of our vital senses. Gentlemen here on the left, you can see, are not paying attention to their surroundings at all. They're kind of focused on their phone. So because of the fact that we're interacting with digital media through our vision or hearing, we're kind of locked into using those two only, right? And it can take our safety measures away, for example. And lastly, it's limited. And it's limited because we have 5 senses to obtain information about our surroundings, about the world, right? But we only use 2 to access digital media. So my research is in the field of haptics. And haptics studies the interaction of the world through the sense of touch. So how people perceive information from the world through their sense of touch. A subfield of that is surface haptics. And surface haptics studies the way people interact with surfaces around them. So for example, how we define a silky surface as silky or a rough surface as rough. My research specifically focuses on placing natural textures on digital devices. So placing a natural texture, such as the cloth that I'm wearing, for example, on a digital device. In the picture over here in the back, you can see a person feeling features of a jellyfish on a screen, like a haptic screen. So there's the visual representation, but there's also there's a haptic representation of what a jellyfish would feel like, which is probably slimy. So how do we do this? How is this done? Well, the technique that we use in our lab is called friction modulation. In essence, what you do is you vary the friction between your finger and the screen as you drag your finger across a given surface. One way to do this is through electrostatic adhesion, where what you do is you build a charge between your finger and the screen, and this charge pulls the finger closer to the screen, thereby increasing the friction. And so as you modulate or vary the charge built up on the finger, you vary the friction given your position on the given screen. Another method is called ultrasonic lubrication, where what you do is you vibrate the screen ultrasonically, and because you vibrate it, there's less contact between the finger and the screen, and so you're decreasing the friction. So, okay, we can vary the friction between your finger and the screen. So what? Well, to display anything natural, display anything important, we have to first collect some data of something that we care about. We have to record textural qualities. One way to do this is by recording the vibrations that are induced on your finger when you drag your finger across a given texture. This is called vibrometry. Another method is to collect the forces that are listed on your finger as you scan the texture. This is called tribometry. In my research work, what I do is I reconcile methods of collecting texture data and displaying it. So I work in the process of recording it. I work in the process of processing it, actually, to get out those important cues that you use for texture perception, and to put them on the screen where you can actually feel it. So one of the most fun things I think about my research is to think about how this is applicable, how we can use this. I think one of the things that we can use haptic surfaces for is to enhance digital experience. So for example, imagine yourself watching your favorite TV show. You could actually feel what the characters are wearing. Or if you're into online shopping, specifically clothes, shopping for clothes, you could actually feel a sweater, for example, that you're trying to buy, or anything else. Another facet of this is that it'll actually enable people to interact with digital screens. So people who cannot access them through vision or hearing, but actually feel them through the sense of touch, right? Lastly, it'll increase productivity and safety. And the reason I mention this is because I think this is the primary field where haptics has been applied recently. Specifically, car companies, now car manufacturing companies, install tactile feedback displays in their cars, so a driver does not have to be looking at the screen when they're driving. You know, they can actually get the tactile sensation back to know if they've actually pressed the volume button or not, or any other button. So I'd like to thank everybody for being here. I'd also like to thank NSF for funding the research and all of these wonderful individuals who work on surface haptics. Thank you.